Let's add some sort of remote control so you can tell the robot where to go. Alright, so basically our setup is going to be using only the Nano for speed and direction control, with two of the channels coming from the Tactic RC controller. Now these feed into the pins that are naturally an interrupt pin, pin 2 and pin 3. Alright, so you got your steering and your motor driver components, and then you got your RC servo meter and your text output. Digital pins 2 and 3 have hardware supported interrupts. Any Mega 328P chipset based Arduino will have two of them. You can ID them by the blue arrow in VISUINO. You want to upload it and get your current high and low values so they can be remapped for a good stable 0 to 1 output. Add two dead zone scaled analog components to remap your RC numbers into a 0 to 1 scale. Now you should get the full 0 to 1 output range. So we're going to take the signal up and around up into the steering component and the H-bridge module. I do highly recommend doing them one at a time, or you're going to end up like this guy pouting in a corner. Now there is a different way to get these values from a remote control module. The biggest thing to remember is that the remote control for a model toy is not the same PWM signal that you're used to for an Arduino. The Arduino uses a negative 255 to a positive 255, so you get that 516 range. An RC model uses a pulse, but it's a time pulse of between 1000. So center is 1500. 1500 is center. 2000 milliseconds is a full, like a 255, and then 1500 is and then 1000 is minimum all the way down. That's why we're getting those ranges from 700 to 300 to 200. It's just milliseconds, kind of being tricky that way. So you have to use Detect Edge. That's a different module. So I hope this one at least helped you out a little bit. And I'm going to close this one out and do some more work on the gyroscopes. Thank you very much for watching.